thank you for having me here. Good morning. I work again at the IV&V facility in Fairmont. And actually Jake and I worked on the MSL project together. I was on the MSL project for about 2.5 years before we finalized or finished up all the IV&V analysis at the end of September. So for the last about a year, I was on as the contractor project lead for it. So right now I've moved on to the SMAT project working with JPL as well. Stephen went over this a little bit yesterday. I just wanted to bring a couple points out of this. Again, we're independent facility with NASA, so we report straight through NASA headquarters. Really our point at IV&V is to make sure that the project is building the right product and that they're building the product right. So those are the two main points that we're striving to achieve. Again, I won't go through all of these, but not trying to sell the facility or anything. But even obviously our side, the feather in our hat is finding the issues that go, wow, glad you guys found that. But the other side of that is from the project side is so that they know when we're done and when they've achieved or they've arrived at all of the readiness reviews for launch or critical events or so forth, that when NASA is asking everybody, is everybody okay with us to go for whatever it is they're ready to go for, that IV&V, when we state that everything is good on our side, that assurance from their side is being received well from NASA. So that's one benefit of IV&V. And the other one is on the bottom side here is the reduction in rework costs. So, and that was kind of pointed out in one of the presentations yesterday, and one of the charts is obviously the later in the project the issue is found, the more it's going to cost to fix that. So if IV&V is working with the project in sync with them as their development goes, then we can provide a lot of value to the project as a whole. The line of communications for how we work with the project, as you can see over here for the MSL development project, they have the software team, is what Ed was talking about yesterday with the flight software, the systems team, and the EDL, and then so forth. But then we talk straight through the PSSE on the MSL project, and that's the same way we work with most of the other NASA projects that we're working with. And then on our side, we have a civil servant project manager, and then this would have been the location where I was a contract lead. And then we had for the MSL team, we had a team that got up to as many as, I believe, 14 or 15. But many of the teams are much smaller just because of the high visibility of the MSL and the cost of it is what kind of forced that function. Again, eye chart here, I'm not going to go through all this, but you can see up here just a general project life cycle phase, going through all the different the phases up here and how we kind of work with that. So we'll start with the init and planning, much like the regular project will do, in the concept analysis. So at this point, we don't have the capability to perform the IV&V analysis across everything on the project. But what we'll do is we will do what's called here as a PBRA, is a portfolio-based risk assessment, and determine what is the most critical capabilities within this particular project that we're going to focus our attention on from the flight software side. Like Stephen kind of said yesterday, flight software is kind of the historical place that we do our work, but we're also trying to move a little bit more into the architectural standpoint of the analysis as well. Moving from the concept analysis, requirements analysis, design, code, test. And then in the case of MSL, in many other projects, you have the iterative development life cycle. So a lot of times this is just kind of a big loop as new builds come out, and you'll see in the MSL that were some of the challenges that not only obviously the flight software development team faced, but also us at IV&V have faced. So as the initial plan for MSL was to launch in 2009. Well, some of the hardware development was delayed and wasn't ready to go. So the launch was a slip to the next potential window, which was about 26 months for Mars. So when in November of 2009, when the restart plan was reorganized and they were figuring out what the flight software development was going to be, this is how it kind of came out generically. This was everything. As Ed had discussed yesterday, obviously there's many phases to the MSL mission. You had your launch, your cruise, your approach, your EDL, which is your entry, descent, and landing, and then your surface operations. So within the original plan, all of these were planned to be, this build was to add those certain features as you had the next build. So at the end, everything was all in the one build line. And it was originally planned to be set up before, or fully developed before launch. Well, as development went on, the project team, the development team, decided that since if we could do all the testing that we needed to do on the hardware, on all the interfaces, that there's no reason why we can't create our simulation models and engineering models to do analysis on the flight software while we're flying to Mars. We have 8 months before that time frame. So in late 2010 is when the project team decided to split off another build. So you can see back here we split off a surface build. Said we'll just continue to develop it in parallel. Many of the functionality within the surface build was unique just to surface build, but a lot of the baseline functionality was also in the launch build, or launch/cruise build. As launch approached in early 2011, they kind of made the same decision at that point to say, well, again, EDL is another 8 months after launch, so why don't we continue as long as we have the simulation set up to perform the flight software analysis on that. Let's go ahead and split that build off into a separate build as well. And then in early 2012, after they made that decision to split off the EDL build, it gave them more time for development. And one of the things in 2009, when everything came back online with the development plan, or the flight software development, they made the decision, it was a two computer system. They made the decision to, during EDL, because the complexity of EDL, and obviously the newness of the landing procedure, they made the decision to run on one computer just to decrease the complexity and decrease the chances of bad occurrence happening. But also, in that time frame, with that added time after 2012, they decided to go ahead and build a kind of a stripped down version of the EDL build, this build here, so that when time came during EDL, you had a backup system ready to go. It was more or less a system fault protection aspect to be able to quickly swap over to that other compute element to take over. And the plan was initially under 2 seconds to be able to quickly swap over, and in case the reset happened on the prime computer. So after all of that, then what we ended up with as we continue on, you can see down here we have an R11 that's continuing actually to be developed now for the final build on the surface. The launch build was developed all the way up here to launch, and then it was when cruise continued through cruise until EDL. The EDL build was developed all the way until the point about 3 or 4 months before the landing. Same with the second chance build. And then the surface build, again, was developed in parallel with all of these as well. At IV&V, like I said, it's independent. We don't have the resources to do the analysis on all the product that's coming from the project. But what we do is do the risk assessment. And where we put our focus on was the fault protection because of just the complexity, obviously, of the system. Entry, descent, and landing, which again was due to the newness and uniqueness of the landing process. The autonomous navigation, there was some heritage software used from MER that was brought over for much of the basic navigation on the surface. But then there's a lot of new autonomous navigation being developed strictly for curiosity. And then also with all the complexity of the sampling and acquisition and handling, that was part of our focus as well. So with the changing in the flight software development plan and how things progressed, we had to answer a lot of questions as we moved along to try to stay in sync and try to make sense of all these builds and make sure we were doing the work we wanted to get done to help assure that the mission would succeed. So the big three questions that from kind of the management of the IV&V team occurred was, how do we keep the analysis and the change impact synced across all these builds, all these development lines? How do we perform the issue resolution across these different development lines as we approach these reviews, as we approach these gateways to the next step in the development? And how do we respond to any in-flight issues while still analyzing development builds? So whereas in some of the IV&V historically is worked, obviously, as Stephen said, came about with the Challenger accident. So a lot of the work we've done has been with the human-rated missions. And within those, obviously, the IV&V analysis has been done while the project is in operations, which we're in science missions, that hasn't been the case. Usually we're done 3 months to a year prior to the launch, and then it's kind of on its own after that. While this one here, we were still doing the analysis while it was in cruise to Mars. So before the launch, as I had said before, the surface build split out. So what we were able to make an assessment there is, again, just as the project did, we made the decision, well, we can at this point defer any of our analysis for the surface until we've gotten through the launch. We've gotten through at least the main part of the EDL, which EDL was our highest criticality, and I'm sure the project as well. Before the EDL build split out, what we were able to do, make the assessment then, is we had a lot of the analysis done on EDL, but we were able to slow down some of our other analysis, our test analysis that we were doing, so that we could concentrate on anything that was required before the launch and be able to have the assurance to be able to give the go for the launch from our side. And then before launch, we had you have these scopes of issues, and the issues are the products we provide to the project. So within that, we had to go through all the issues that we had open against the project, be able to identify which ones would be pertinent to the launch or early cruise or anything along those lines, which ones were pertinent to EDL, and which ones were pertinent to surface. And then in some cases where it's a baseline function, it could be an issue against all three of those development phases. After launch, one of the things, as I had said before, was the on-flight on-flight reset. We were able to utilize our knowledge to assist the project as much as possible with the analysis of why the system reset. It was about 3 days after the launch, and since we had the team still operating, we were able to jump in and help with that as much as possible, but then also continue on or ramp back up onto our surface build analysis, and then also continue on with the EDL analysis. After the launch, or in 2012, after launch, after the on-flight reset was resolved, basically the cruise launch build was pretty good at that point and really had no more problems on the way to Mars. But then we jumped back into the second chance build as it split out of the EDL build, and continuing on with the other analysis. And then pre-landing, we had to do the same thing we did with launch, whereas the project concerned with what was EDL specific as far as open issues and open burn down of those issues, but also early operations on the surface, so that they know once the EDL had successfully occurred, that once you're on the ground, that you were in a safe condition and able to receive and communicate back and forth to Earth. It was the primary concern there. So the resolving the issues, like I said, we had to split those out into different. The way we have it set up is we have a issue tracking tool called Orbit, which is built out of MKS Integrity, and we needed to have the flexibility to not only on our side to understand, which issues that we've created or found are pertinent to each of these different builds, also how to communicate that to the project, and so that they were in sync, we were all in sync together as far as what needed to be done prior to any of these gateways. We had to evaluate each of the they're called TIMs, technical interoffice memorandums. We had to decide which ones were with the EDL and surface so that we could push those off, or in some cases make those spread across all three of those different builds. So we ended up creating different projects within our issue tracking system that was able to, not only on our side, make it easier for us, but I think more importantly on the project side, so that they understood where they stood with what needed to be done for the reviews. The in-flight anomaly, which happened, it was day of the year 333, we had done some analysis on some problem failure reports that the project had put forth at the launch reviews. These PFRs there were resets that occurred during testing, but during the thousands of times of testing, these resets only happened like a handful of times. Different resets only happened a handful of times, and there was really no way to recreate them. They couldn't recreate them. They couldn't trace them anywhere. So they were accepted as risks, but again, because you're only talking about a handful of times the resets occurred over the thousands of times the tests happened, then the risk was very small for that. Well, it turns out after the information came back through from the spacecraft on the reset, that a few of these PFRs were actually linked together with the reset that occurred on orbit. And what it was ended up being memory management configuration on the compute element that was easily correctable and it actually never really need to be bypassed in any way or form. So, but what we were able to do is rule out that the flight software at IV&V was able to rule out that the flight software was not the concern for the reset. In fact, the flight software had done exactly what it was supposed to do, and by going into the safe mode. So what we learned through MSL, which it was a long process, but we wanted to, we had to be flexible. I mean, as a development team, obviously they had their challenges and they met those, but we also had to follow along with those as they changed their development plan. So we had to be as flexible as possible when it came to terms with the development plan. We had to reprioritize what we were concentrating on so that we can stay in sync with them, not only stay in sync with them, but also be ready for the reviews that the NASA headquarters would be putting forth. The cross-analysis provided by the analysts, that kind of is from our side, is having the analysts be able to work on different aspects of the mission, so that when we made those changes, when we made the changes from EDL to surface and back and forth for the focus of our analysis, we wanted to be able, or the analysts had the background to quickly make those change of directions. Having the right tool set the right way, obviously, is always critical, and in this case, really helped us have be able to provide the assurance to the project. And then having the flexibility to draw on the past analyst experience during the resets or any on-orbit concerns. So in most cases, especially for science missions, we will not have the team up and operating at that point in time, but we would be able to quickly pull that team back together in these cases. So I think that's a pretty important capability to have. Some credits to some of the past project leads and everything with our PSSE out at Sandy Krasner out at JPL. So I think that's it. Any questions? Yes.
When you're doing your validation, how are you doing that? Are you looking at their code, or you're running a simulation? What are you doing?
The validation aspect is broad in the fact that we'll take their functional design documents, we'll take their ICDs, take any sort of design project that depending on how they're doing their development. So validating the design meets all the criteria, validating the requirements that come out of the design, and then eventually validating that the code matches the design that they've come forth. So we won't do it across all the software because we just don't have the manpower to do that. But we'll do those on those critical areas that we've assessed the risk assessment to. So.
But you don't run
Steven has a lot of that, the ITC group back there. They do have the capability to run the software. We run them through static code analyzers. I know in the case of MSL and SMAP, we are actually utilizing their workstation tests at Wistis to do some of our testing. So on their system, they've got the builds running, and we have the interface into those to do the testing we want to. Test scenarios, test out fault scenarios off nominal and so forth. So, yes?
So I think you answered his questions for the validation, mostly of the design and the requirements that come out of it. So maybe be a little clearer in the testing aspect of it, on the workstation or in the test bed. Are you verifying requirements, or are you in IV&V or validating via test problems, or just trying to generally break it and find defects? What
Yeah.
Well,
we're actually kind of in maybe a little bit of a transition there. Historically, what we've done is kind of for what we do for test analysis was kind of a piggyback of what the V&V does for the particular project. So the V&V on the project will have their test plans, and they'll have their test results. And so what we would normally do or historically do would be to take those, based off requirements. See if they're fully testing a requirement, nominally, off nominally, and then also see what the results are to verify that the results are what we were expecting. So we would write issues there if we felt like they weren't fully testing a requirement. So most of that was requirement based.
So that's looking over the shoulder of the V&V team,
right.
Making sure that they're comprehensive in what they're doing.
Right. But right now we're really in a transition trying to move to that next level of being able to do the independent testing on our own, so not being reliant on the project to come up with their plan and come up with their scenarios, but for us to be able to do the same thing. And that it varies depending on what the project can and is willing to provide to us. I know, like Steven said, they actually have the executable for some of the projects that they're able to run and create the simulated inputs to into the software. Like I said, ours is run through the project, and so we're actually trying to work our way through how we can manipulate certain things, certain capabilities, inputs, whether it be like sensor inputs or anything along those lines, to create our own scenarios of where faults may occur or multiple faults or things like that, and see how the software responds. So that's where we're trying to go to and again, it depends on the project, depends on the developer and what they're willing to provide to us and can provide to us. But right now, that's where the facility is trying to head to, is complete, really independent testing and not trying to, like I said, look over the shoulder of the V&V.
Any other questions? No? Okay.
Right.
Good news. I want you all to observe this. Software is, thank you, ahead of schedule. Well done. So thank you very much.